So I won't go into a lot of detail. I have a lot of intro slides here about flame retardants. A lot of this has been covered. This is just one of the standard definitions of a flame retardant. And it's always important to point out that people have this conception that flame retardants prevent something from catching fire, and that's actually not true. They still catch fire. It's just supposed to slow the rate at which they spread. And a lot of the information in the video focused on residential furniture, and that has been a big area of research, but it's important to realize that these chemicals are used in multiple consumer products and equipment. There's just a few here that I listed. They're used heavily in electronics, TV sets, computers, your Blu-ray player. They're also used a lot in wiring and cables and electronic equipment because all these things can generate heat, and there's concerns about them being an ignition source. And most of these are applied really to meet certifications for insurance requirements. And then there's a lot pertaining to textiles, and there's also some village standards related to insulation in buildings as well. Very different standards for public places versus residential settings as well. And it turns out now that most of our exposure, and it's estimated about 80% of our exposure to these chemicals actually comes from contact with dust particles in your home or inadvertent ingestion. We don't think about ourselves as ingesting dust particles, but we do get exposed to them, sometimes through inhalation, and sometimes just by touching things. We don't see particles, but they are particles on our hands, and they can be transferred through food contact. If you're eating pizza or French fries, that's a transfer route. And so it's become quite clear in the US at least that exposure to house dust is the primary route of exposure. And this is a big concern for kids. It was well known for several decades that exposure to lead was through accumulation of lead in house dust, so it used to be applied to paint. Well, flame retardants were following the same paradigm. They are accumulating in dust, and children were having higher exposure to them. And when I started at Duke, there was very little research done on children, most of it focused on adults. It's very difficult to collect blood samples from children to understand what their levels are. But I thought this was very important and won a proposal and was funded to do this. And children spend so much time indoors, more than adults. Toddlers and infants spend a large amount of time crawling on the floor. They have a high number of hand-to-mouth frequencies, so they have higher exposure to dust and any chemicals that are on the dust. And concentrations of these flame retardants in dust are orders of magnitude higher than you see in soils. And so we've done this twice now, one focusing specifically on baby products, because baby products were meeting that California standard, TB 117, and then a follow-up study focused specifically on residential couches or sofas. And we do this, and it's not all that hard for people to have a chemistry lab, although not for the general public, I understand, but we actually reached out to many different people that were interested in this topic and asked them if they could donate a very small piece of foam. We only need a marble-sized piece. Asked them to cut it out of their product, a baby product or their sofa, and actually wrap it in foil and mail it in to us. And we place it in a test tube with some solvent. And then we just use sound waves to kind of shake that foam, and these chemicals come out very easily. They're additive, they're not chemically bound, they come out very easily. And then we can take that solvent and we run it on a mass spec. So if any of you watch CSI or NCIS, they're always using mass specs. They make it look very easy. It's a little more challenging than they show on the TV shows, but it's basically the same approach, is that we're injecting this onto an analytical instrument, kind of takes a fingerprint of the sample, we run it against a database, and we try to identify the compound. Now, some flame retardants are in databases, some are not. Some we can kind of deduce from the information the mass spectrometer provides. So for example, you heard about chlorinated tris and the toxic hot seat. This is what comes off a mass spec, and basically those peaks represent chemicals that we detect. And in this case, it produced a fingerprint that was a match to chlorinated tris, and we actually had an authentic standard to compare it and positively confirm it had TDCPP. So in this specific study, we actually tested over 100 different baby products, and these are primarily products like car seats. So we did some strollers, changing table pads, portable mattresses, nursing pillows, these sleep positioners that are used to prevent children from rolling back on their stomach to prevent SIDS. All of these contain polyurethane foam, and all of them were considered juvenile furniture at the time and were meeting TB 117 standards. After screening all of them and analyzing them, we found that 80% of them did contain a flame retardant we could identify, and the most common ones were chlorinated tris, or TDCPP, Firemaster 550, which is a new mixture put on the market to replace Penta, and another one called V6. And so I'll talk a little bit more about them later on. We did find Penta in 5 samples, and those were older samples that were still in use, which is pretty common. We identified some new flame retardant mixtures we didn't even know were being used. In this paper, in this report, we tried to highlight the fact that risk assessments were not actually being conducted to assess children's or infants' exposure to these chemicals. And as they adequately pointed out in that video, a child sleeping on these products for a significant portion of the day is going to have much higher exposure to these chemicals that are off-gassing from these products than an adult that's 10 feet away. And we've actually been doing experiments in my lab to measure exactly those endpoints. I have an undergraduate student, and she just completed these experiments, and I looked at the data actually just last week, and I was pretty shocked to see how much was coming off of some of these sleep positioners, quite honestly. They talked a little bit about chlorinated tris in the document. Here's some additional information. It was used in children's pajamas back in the 1970s until it was found to be mutagenic and was voluntarily phased out after studies conducted by Arlene Bloom at UC Berkeley discovered that it was a mutagen. The National Toxicology Program also did a long-term study in rodents and found that exposure led to increased incidence of tumors. So that was a National Toxicology Program. One of the more interesting reports that I've come across has been a study conducted by the Consumer Product Safety Commission. It's a public report issued in 2006, where they tried to estimate exposure to a family in a home where a furniture set was treated with TDCPP or chlorinated tris. Now at that time, they actually didn't have the money to run an experiment. They didn't have any data measurements of these chemicals, so they modeled what they thought exposure would be based on its physical chemical properties. If you go to this report, it basically states that based on their model, they expected exposure for a children and an adult to be higher than the acceptable daily dose, meaning that there'd be more exposure than what they considered safe for an increased risk of cancer. But because it was based on model data, nothing was really done. I also wanted to mention FireMaster 550 because this is also of a great interest to me. When it came on the market as a replacement for Penta around 2004, they had this advertisement on their webpage, and I've circled this point here because it says favorable environmental profile, not a PB or T, meaning that it's not persistent, bioaccumulative, or toxic. This has been since taken down. I don't think they show this anymore because at that time there was actually no data on this chemical or what its potential toxicity was. So we actually were able to get a sample of FireMaster 550 and we did some testing on it and found that in rodents it certainly did cause some endocrine disrupting properties. And then we started looking at exposure to this compound. And so here is FireMaster 550. I know we don't get into the chemical structures. It is manufactured by Chemtura and was specifically targeted as a replacement for Penta. And now the EPA did become concerned about this chemical in 2005, and they actually required the manufacturer to do more testing on these compounds, which I thought was the entire mixture, but later found out it was actually only asking for testing on the two structures on the bottom. The brominated compounds they thought would be of more concern. So really no studies conducted on the entire mixture until my colleagues and I at NC State did a study with pregnant rats and found out that exposure to this compound caused a variety of problems in the pups that were born, including weight gain, early puberty, and effects on thyroid hormone regulation. I know I have a lot of information I was sharing. I'll try to wrap this up, but I wanted to mention some other things that we're trying to focus on in our group. We just did the study with toddlers. Again, because a lot of the infant products contain these chemicals, we're very interested in understanding what the levels of exposure are for infants that are spending a lot of time with these products. So we have recently collected urine from 50 infants, less than 12 months of age, and we are in the process of analyzing those now to determine if levels are higher. Given there's a lot of talk about cancer and toxic hot seat, and given the similarity in structure with thyroid hormones, there's been a lot of interest in exploring whether or not increased exposure to these flame retardants is related to an increased risk of developing thyroid cancer. Thyroid cancer is actually now the fastest growing cancer in the United States. It's been documented not only in the US, but in other countries as well. I'm now working with some doctors in Duke Cancer Institute because there's been some suggestions just due to increased diagnosis, increased radiation exposure, but it seems quite clear based on more recent data that it has to be environmental. And so it's great to work with doctors now, and I think they're really interested in this and trying to understand what these environmental exposures are. And so we just started this project last year, and so we're hoping to continue that in the future. So just some ending discussion points. I know there's it's, as they say, a hot topic. Flame retardants, do they provide benefits, do they not? I think it's certainly important for us to maintain fire safety, but I think there are ways to do it without using these small chemicals that just leach out over time. We have to figure out where they need to be used in the first place, where they don't need to be used, and can we use alternative technologies and strategies to maintain fire safety without leading to exposure among the entire population. This is also a case in point for TSCA reform, as many of you are probably aware of. And I think we need more transparency in chemical use. As a scientist and mom, I find it very vexing that a mom can go out and want to do the best thing for her child, and if she might be concerned about a chemical or carcinogen in her nursing pill or her children's car seat or her portable mattress, she has no way of getting that information. And even if you call a manufacturer, more than 50% of the time, they don't even know what chemicals in there. There's just no information out there. And so you're never going to know. And I think that's really unfortunate that our laws protect the chemical industry and doesn't provide the information we need to evaluate risk or make more informed decisions.